Hi guys, today we'll talk about find median from data stream. Let's go through the statement. The problem statement says the median is the middle value in an ordered integer list. If the size of the list is even, there is no middle value, and the median is the mean of the two middle values. In case of example 2, 3, 4, we get 3 as a median because number of elements in that array is odd, so the middle element will be the median. In case of even number of elements, we will take the middle two elements and take their average. That will be the median. What was expected from this question? They were asking that we have to make a class, we have to implement median finder that will initialize median finder object. We have to implement add num function, which will get some number as a parameter, and it will keep on adding that numbers in some data structure from the data stream. We have to also implement find median that returns the median of all elements so far. Answers within 10 raised to the power minus 5 of the actual answers will be accepted. Let's go and understand this question by example. Okay, so before going through that question and understanding that, we would make a protocol that how we will follow to solve any question. We will follow Reacto, which was also been explained in many other places. What is a Reacto? So from Reacto means that or means that we will repeat the question in interview or in our normal day-to-day job conversation when we were dealing with any task. We have to repeat it, or we should read it, anything. From E, we were expecting that we will try to understand that question by an example. Third, we will try to explain our approach, that this is the way that we can solve this question, so that we can get the opinion that how it could be done in some other better way. From C, we'll start coding, and from T, we would start testing our code, and from O, we'll try to optimize. Now we talk about that repeat part. We have already read the problems. Sorry, we have already read the problem statement that we have to find median. We have to find median and how to implement some function. So our repeat part is done. We will now go for the next part to look for example. Let's understand this question by an example. Suppose we have 1, 2, 3, 4, 5, 6. In case of even numbers, always go with very basic, simple example so that you can digest the question in very short time. We have some, let's suppose, numbers 1 to 6. Count or size is even. We will go into middle two part. We will take their sum and divide by 2. That will be the median. In case of 1, 2, 3, the count is odd. We have odd number of elements. We will go just to the middle, and that will be our median. Now, when we go through the example, we go in further details. We analyze the question in a way that we can get some approach. We can create some approach in our mind, and we can apply that implementation. In case of approach, first what we can do, we can go and think about we can look into some question what we have done already similar to that, or might be some part is being done similar like this. So we can think about two heap coding pattern that can give a clue that why we have to go with two heap coding pattern. See, first, if I will look at the number 1, 2, 3, 4, 5, 6, I can see that I can divide this number. I was expecting middle two element from here and from there, so I can see that this part of those numbers is increasing, and that part of these data stream is increasing also, and I need two elements from two parts. The one part which is like a max heap, the second is like a min heap. So this is max heap, this is min heap, because if I will see that this is 3, 2, 1, that is a max element at the top, and 4, 5, 6, so this element on the top, so this is a max heap, and that is a min heap. So what we can get from here, that we can think about two heap coding pattern which may solve this question. Well, that is interesting. That, yeah, of course, that we have to go and find these two middle elements. But how about the odd number? In case of odd number, for sure, let's suppose 1, 2, 3, and in that case, if I will use my max heap, like 2 and 1 and 3, in this case, what we can do, we can make a trick for this max heap. For that max heap, I can do one thing. I can count, so this is min heap, I can count the number, the size of both of these heap, if S1 and S2, if I plus that, they are odd. So I can just pick this number from the top of max heap. This is what is required. So yeah, we get some idea, we explained our approach. Well, we have already gone through reactor repeat, example, and some approach. But we can still complete our approach. We can explain that part with the specific function. So let's see, in case of add, what we will do. So this is the number that we are expecting, and we have these two data structure. This is a max heap, this is a min heap. Let me color that for better understanding. So this is a min heap, this is max, and this is min heap. I just make a convention to be at the top. The broader is max, short size mean that this is min heap. Okay, so if I say add, in this case, what I will do, I will see, first look into max heap. If it is empty, either it is empty, or the number which is here is greater than the number which was being passed. So if that box which is at the top here, if that box is greater than that number, in this case what we were expecting, that this number for sure falls here, so we will just add it in max heap. So in this condition we can just add it in the max heap, and for sure we can think about some example like this: 6, 5, 4, 3, 2, 1. In that case, 6, when it will come at the top, so it will remain here, then we will send 5, 5 will go down, then 4, and 3, 2, 1. All numbers will go into max heap and min heap will be empty. In this case we were not finding the correct median. So what we should do, we should normalize that. And what will be the normalization? In normalize, what we'll do, we'll keep a balance in max heap and min heap. So for the max heap and min heap, we think that the difference between the elements should not exceed more than 1. So the max heap size and min heap size, that difference shouldn't be greater than 1. In that case, for odd number of elements, max heap can keep, let's suppose, more than 1 element. That will be 2 and 1, and min heap will keep only 3, and that was our required number 2. So this is the median. This is what we were expecting. In case of even number, for max heap we were expecting 2 and 1, and for min heap we were expecting 3 and 4. So this number 2 and 3 here, they both will submit. So we'll say 2 plus 3 divided by 2. That will be the median. Now that makes clear sense. So we have to normalize that. Whenever max heap size grows with that particle difference, we should shift some number from max heap, from the top of max heap to the min heap. Suppose we have 3, 2, 1, and it contains only 4 here, and let's suppose let me make it better. So not like this. Okay, so I was talking about, suppose we have a max heap, here 3 and here's 1, and here we have 4. Now if we send 2 in add, so when we will see that 3 is greater than 2, so we were expecting to add it here. So the next shape will be, after adding, will be 3, 2, 1, and here will be the 4. Now the next step would be normalize. Let me make it here. So the next, what we can do, we can normalize here. We can normalize. In normalize, what we'll do, we will shift 3, 2, 1, the top element, from max heap to min heap. That would result into, that will be, that would be a max heap, and that will become 2 and 1, and this is min heap, which will become 3 and 4. So we can take these two numbers and add them and make an average. So that will be the median. Now let's go to the code and see how we can implement that. Let's see how we can implement that. So the first thing first, we know that this belongs to heap coding pattern. Now what we can do, we can initialize our data structure, which will be min heap. Min heap will be, we can use a priority queue of int, and its ordering will be pretty much natural with the integer ordering, and we can reverse it because naturally it's going to be in ascending order. And we can go with wall max heap. In max heap we can say priority queue, which will be int, and we can go with, we don't need to mention ordering here, but for the sake of clearance I am just adding it here. I will also tell it belongs to import scala dot collection dot mutable, because priority queue is a mutable data structure in Scala. Now how we can implement add num? What we talk about, that first we can add that number, and then we can normalize our data structure. That's what we will do here. Instead of going into the details of writing the whole code, it's best approach that we can divide our complete problem into very small function and just mention it here. and later go for the implementation. That makes a complete approach. That from approach, what you have mentioned, you are going to give the same picture, the same implementation here, with might be some changing, but okay. Let's go with implementation of add. What is meant by add? So we were expecting we are going to add the number which was being sent here now, and this function is not going to return anything. This is a local function, and with the first condition, what we were thinking about, that if max heap is empty or max heap dot head is greater than equal to the number what we were getting. In this case, max heap dot enqueue this number, else min heap dot enqueue this number. So done. This is what we are talking about, enqueue, about add. Now for the second phase, because we talk about that when there's a chance that we may get some number like 6, 5, 4, 3. So in this case, all numbers will go into max heap. How we can normalize that? So normalize, we can say it will return again nothing unit, and we can simply consider that if max heap dot size and min heap dot size, that difference is greater than 1, in that case what we will do, what we can do, we can make two separate size, that max heap, we can say max heap size, that will be max heap dot size, and will min heap size, which will be min heap dot size. And I can use here simply max heap size and min heap size if the difference is greater than 1. So we will dequeue, because max heap is now keeping more than one element, just the case what we talk about, 3, 2, 1 in min heap, max heap, and 4 only in the min heap. In that case, we have to shift 3 from max heap to min heap. The min heap will say, I will enqueue whatever max heap is going to dequeue. So it will get that. Else, if in any case, let's suppose we get max heap size less than our min heap size, in that case max heap enqueue whatever min heap dot dequeue, whatever it will dequeue, we will just add it in the max heap. That's it. Yes, this is what we were expecting in normalization. And what will be the fine median? For sure, it will be very simple. If max heap dot size is equal to min heap dot size, it means both of those periodic queues contains same number of elements, so we don't need to take the mod and consider the size equal to 0 or no. If their size are equal, it means that they contain even number of elements. And what we can do, we can say max heap dot head plus min heap dot head divided by 2 pi tau, because this will convert into implicitly into double. Else, in case max heap will contain, because we have already normalized here in add function, and when someone says find median, if odd number of elements will be, so we can just dequeue the element from the top if max heap. So max heap dot head is what was expected as a median. That's it. We can test it, we can look into that further, that we have two data structure, and we can go step by step by considering any input. Like we may take some example, like we were expecting 1, 2, and 3, and then we can apply add num to them and can keep on watching about the data structure, how it will be. But let's run here. So it's working, and we can talk about optimization hopefully in all other questions later. Thank you. Bye.